You shipped a production feature without writing a single line of code. 5 Claude Code agents did it in 11 minutes from Jira ticket to merged PR. One of the agents found a failing test. It fixed the bug automatically. No human got paged. This video shows you the exact architecture that made it happen. You've probably seen the demos. And I write some code, it mostly works, you fix the rest. That's not what this is. Every video on Claude Code multi-agent shows you the happy path. Spawn agents, watch them run, look at the output. None of them show you how to constrain what each agent can touch. None of them show you how a queue of failure automatically requeues work back to the dev agent with no human action. And none of them show you what happens when it goes wrong. There's a documented production bug where a subagent recursion loop consumed 1.2 million tokens in 30 minutes. The fix is 3 lines of hook code. We'll get to that. But first, here's the part nobody is teaching. How you constrain agents so they stay in their lane, and how you build handoffs that survive a context reset. There are 2 ways to build a multi-agent pipeline with Claude Code today. Subagents are stable and generally available. You define them as markdown files with YAML front matter. Each one gets its own context window, its own system prompt, and a specific list of tools it's allowed to use. Handoffs happen through files written to disk. The orchestrator reads those files and decides what runs next. Agent teams are experimental, disabled by default. The difference is communication topology. With subagents, an agent can only report back to the orchestrator. Agents never talk to each other. With agent teams, teammates share a task list and can message each other directly by name. For a sequential pipeline like this one, subagents are the right choice. They're stable, lower token cost per hop, and handoffs are explicit and auditable. Agent teams become useful when you need parallel independent work. We'll come back to them at the end. Each agent is a markdown file in .claude/agents. The YAML front matter at the top defines what it can and cannot do. Product agent, read, write web search only. It can read the codebase, write a spec, and search for PI conventions. It cannot touch source code. Dev agent, read, write, edit, bash with a constraint. A PreToolUse hook blocks it from running Git commands. That authority belongs to a different agent entirely. QA agent, read, write, bash, but bash means test runner only. It cannot edit source files. Testing agent, bash and read nothing else. Run the tests. Write the result to a file. Done. Deployment agent, bash only, no edit at all. A PreToolUse hook filters every bash call. If it's not a git or gh command, it's denied. 5 agents. 5 sets of hard fences, not prompt instructions, not polite suggestions. The model cannot reason past a hook that exits with code 2. That's the difference between a system that holds its shape and a demo that works until 2 a.m. when nobody's watching. This is the enforcement layer. A PreToolUse hook fires before every tool call. If it exits with code 2, the call is denied, not warned, not logged, denied. The model gets a hard stop. Anthropic's own documentation says it directly. When something absolutely must not happen, an instruction is the wrong tool. Models occasionally violate rules under ambiguous conditions or pressure. Hooks cannot be reasoned past. The dev agent's hook is simple. If the command contains git push, exit 2, the deployment agent's hook is the inverse. If the command is not a git or gh command, exit 2. 2 hooks, 3 lines each. The entire permission model for your 5-agent pipeline. When one agent finishes work, it writes a JSON handoff file. The orchestrator reads that file to decide what runs next. 6 fields matter. Feature ID so the orchestrator knows which feature we're routing. Status, dev complete, queue a failed, queue a passed, or deployed. From agent and to agent, who wrote it, who should read it. Failures array. If queue a failed, this contains the exact test name, the assertion error, and the line number. And here's the field that prevents your pipeline from burning your API budget: retry count and max retries. Max retries defaults to 3. After 3 failed dev attempts on the same feature, the orchestrator writes to a human escalation file and stops. No infinite loops, no silent retries. That's the schema. Now let's watch it run. The ticket is feat 1024. Add automatic JWT refresh. When a request arrives with an expired token, return a new token in the response header instead of sending a 401. Simple, real enough to touch authentication, small enough to show end-to-end. Product agent reads the ticket. It searches for the bearer token conventions. It writes the spec file. The spec has 3 acceptance criteria. 1. Expired token returns a new token in the authorization response header. 2. An already valid token passes through untouched. 3. A tampered token is rejected with a 401 no refresh, no bypass. 2 minutes of real elapsed time. 1 spec file. Product agent's job is done. Dev agent reads the spec. It reads the existing middleware structure, so the code matches the project's conventions. It writes the JWT refresh middleware about 40 lines of Python. It cannot push this to Git. It writes to the handoff file, status dev complete, to agent QA. QA agent reads the spec and the implementation. It writes 3 tests: happy path, already valid token, tampered token. The test file goes to the auth test directory. Handoff file, status QA complete, to agent testing. Here's the part most tutorials never show you. What happens when one of those tests fails? Testing agent runs PyTest. 2 tests pass. The tampered token test fails. Assertion error, expected 401 got 200. The middleware is not rejecting tampered tokens. It's letting them through. Here's where most demos end. You see the green results and move on. This is what actually happens in a real pipeline. Testing agent writes the full failure to the handoff file, status QA failed, to agent dev. Failures array, test name, assertion error. Line 42. Retry count, 1 of 3. The orchestrator reads the handoff file. No human action, no Slack notification, no pager. It reads status QA failed. It reads retry count, 1 of 3. It passes 3 things to the dev agent: the original spec, the failing test, and the handoff file. The dev agent reads the middleware again. It finds the bug: the signature verification was returning true on a decode exception instead of false. 1 line fix. It updates the handoff file, status dev complete, to agent testing. That's the loop. No human typed anything. Testing agent reruns, 3 for 3. It writes status QA passed, to agent deployment. Deployment agent runs git commit, runs GHPR create, CI triggers. Total elapsed, 11 minutes. The PR is merged. The feature is in production. You didn't touch the keyboard. 3 things will break your pipeline if you don't design around them. First, infinite recursion. When a subagent hits a permission denial, it can spawn a child to try a different path. That child spawns a child. A documented production case hit 50 levels deep and burned 1.2 million tokens in 30 minutes on a task that should have been a 2-minute Git clone. The fix is the PreToolUse hook with exit code 2. When you deny, you hard stop, you don't suggest a workaround. Second, silent retry loops. An agent failing a command doesn't crash, it retries. A documented case saw the same broken command run 200 times, burning tokens throughout. The fix is the max retries field in your handoff schema. Once the orchestrator reads retry count equals max retries, it writes to the human escalation file and stops. Normal software crashes. AI agents fail silently. You have to build the stop condition yourself. Third, token burn on parallel workloads. Each agent repays its own context window. With 5 agents, you pay context cost 5 times. A runaway case burned 1.7 million tokens in minutes with 0 useful output. Use subagents for sequential pipelines. Save parallel concurrency for when tasks are genuinely independent. When you're ready for parallel pipelines, your QA agent checking one feature, while dev implements another agent teams are the upgrade. Set the experimental agent team's environment variable to 1. Teammates can message each other directly by name without routing through the orchestrator. The AWS sample repository on GitHub demonstrates a 4-agent team, a lead agent on Opus for architecture, a coding agent on Sonnet for implementation, a DevOps agent on Sonnet for infrastructure, and a review agent on Opus for quality gates. It's production pattern code worth reading before you build your own. The explicit caveat: agent teams have no session resumption, known task status lag, and no nested spawning. Run them in non-critical workloads first. The Claude.md, all 5 agent definitions with their YAML front matter, the handoff schema, the PreToolUse hooks, and the orchestrator loop from this demo are in the repo linked in the description. Every file is commented with the specific failure mode it prevents. If you want to run this pipeline headless in CI, no interactive terminal, no human watching the next video covers the Claude Agent SDK. That's the same runtime that powers Claude Code, now available as a Python library. Drop a comment. What workflow would you point the queue a rejection loop at? If that's the kind of AI engineering content you want more of, subscribe.